This is the circle, page 193. The first one we're going to do is number 1, and actually we're going to do it kind of a different way because we don't know the actual radius of this concrete pillar, but we do know that its outside tangent to it is 9 inches. Well, if you complete that and make that a square, you would end up with a square that goes through the diameter of the circle. I'm going to show you what I mean. So you've got this part right here, and if you would, so your tangent here and here, if you would complete that, you would have, this is the radius, because these two are the same. So we actually have a 9-inch circle here, and what we need to do is to find out the area and the circumference. So the first thing, the circumference is pi times 2 times the radius, which is 9, and we get 18 pi, which is about 57 inches. And then it says find the area of the circle, so we would say 9 squared pi, and that's 81 pi, which is about 254 square inches. Next one. Here we see the diameter of the circle is about 37 inches. Okay, so if we know the diameter, we are looking for the radius, so 37 divided by 2, divided by 2 is 18.5. And then we're supposed to find the area of that circle, and so we're going to take that squared times pi, and we get about 1,075 square inches. Next one. Here we see all 3 of them, and I'm going to show you how they are related. Obviously, the diameter, the easiest way to do that would be to just double the radius. But let's find the area by taking 19.74 times, or squared, times pi. And if you notice, we don't get the same answer that they did because that answer is in square yards. So we're going to divide our answer by 9, and we get the 135 or so. They had a different rounding than we did. And then finally the circumference would be the 19.74 times 2, because remember it's pi times the diameter, and we get 124. They say 0.02, we add 0.03. Feet. Next one. We are supposed to, let's see, what are we looking for here? Oh, we're going to, this crop circle, or irrigation circle, is inscribed in a square. So what we're going to do is inscribe a square inside this square, somewhat in the lines of the drawing at the top of page, or on this side column of page 194. So what we need to do is to see the largest square that we can get inside here. And it's kind of easy to do because what's going to be true is that the diagonals, or the diagonals from the center of the circle, are going to go through both of those corners of the circles. Well, we know that this is 1 mile on a side. And what question did they ask us? I forgot. How much larger is the side of the square circumscribing a circle 155 centimeters in diameter Okay, so this is 1 mile. So the radius of this circle is a half a mile, or 5,280 divided by 2, 2,640 feet.
Who knows? Because I think it's because the brackets will open up.
And then the diameter, of course, is what they're given. Diameter is 5,280. So we want just the side of this one. 5,280 compared to the side of this one, and they want that as a fraction, not as a not as number of feet, I don't think. Well, we'll do it both ways. Okay, so what you need to see is that in this triangle here, this distance here is 2,640 feet because it goes right to the edge of the circle. This is S, and this is S, so we have S squared plus S squared equals 2640 squared, or take the square root of both sides. 2S squared is 2640, and tell you what, let's do it the other way. Let's do this. 2S squared equals 2640 squared. Divide both sides by 2. We have S squared is 2640 divided by 2 squared. And then we can take the square root of both sides. So on our calculator, we'll take square root fraction 2640 squared over 2 will be 1,866 feet. Now remember, that's half the red square, so that's 3734. 3734. So if we, I'm not sure what they mean by how much larger. So let's do it both ways. So we can take 5280 minus 3734. That is, it is, oops, 5280 minus 3734 is 1564. So if you subtract, it's 15. If you divide 52, and this is what I think they mean, 5280 over 3734 is, it's 1.414 times as big, or in other words, the square root of 2 times as big as the smaller one. Next one. The other thing that we have to do with this square is, like you see in figure 673, we want to see if we would take this field and we're going to cut off part of it. And the part we're going to cut off is this part right here. And they want us to know what is this distance right here. Well, we know the radius, or I'm sorry, from one side of the circle to the other is 5,280 feet. It's 1 mile. Okay, so if that's true, we want to know if this distance from here to here, from this spot to this spot, is 3,186 feet. What is this distance x right here? To figure this one out, what we can do is show that this is the radius, 2640, This is the radius, 2640. If that is true, and this is the radius 2640. Since this is 3186, half of that is 1593. So we can figure out how much this part here is by using our calculator. So we're going to press, we're given the hypotenuse, so that means that we take the hypotenuse and subtract 2640 squared minus the 1593 squared will tell us that this side here is 2105, and if we take 2640 minus that answer, we'll get 535 feet is this part down here. Next, number 10, find the distance from where these, I'm going to have to get the drawing pad again. Find the distance from where these circles meet right to here, if you know that this radius is 2,186 feet, and we want to know, I'm on number 10, the distance from O to P. Okay, this distance right here, from here to here, is about 11,350 feet. They want to know the distance from here to the center of the circle. Oh, I'm sorry. Yeah, that's, they want to know how long is this road here, sorry. How long is this road that goes there? Because this is the perpendicular is right here. So that's the hypotenuse is 11,350. Make sure I got it right. Yep, that's right. All right, those distances are in feet. Now, since this is 2186 is the diameter, we need to take half of that to get the radius 1,093 feet. So we're looking for the hypotenuse again. We would take square root 11,350 squared plus 1,093 squared is, and if you notice, it's just barely, it's not even 50 feet longer than the than this longer leg. And the reason for that is the skinnier the triangle gets, the closer the long side is to the hypotenuse. Remember, that only works with right triangles. Here's an interesting one to show you. This goes with number 11. And if you look here, this is 16 is one side of the circle. And this is 20 and a half is the other side. An angle inscribed in a semicircle is a right angle, and that proves that this is the diameter of the circle. From here to here is the diameter of the circle. So we can use our calculator to determine what that length is. We know the one leg, we're looking for the hypotenuse, so we're going to add 16 squared. That's the one leg. Plus, and I said 21.5. And that shows that the the diameter of that circle is 26.8 inches. So the diameter would be 13.4 inches. Next one. Here we see the circumference of this flagpole. We can determine its radius by taking the circumference 2 feet, so I'm going to rate it as a fraction, 2 feet 8 inches, so 2 8/12 feet. So that's the circumference, divided by pi is 0.84 feet, so multiply that by 12, gives you, it's about a 10-inch circle, or 10-inch diameter, 10-inch diameter flagpole. Here's another one. This is number, I forgot what the next thing that we were supposed to do was. Number 12. Okay, here we go. What is the diameter of this? If the circumference is 73 feet, so we're going to take, this is the pond at Wilson Park in Eau Claire. 73.34 divided by pi gives us, it's about a 23-foot fountain. Number 14, it says, I'm sorry, this is actually closer to number 16 because this is a big circle. The radius, the distance around the circular park is 2.5 miles. So the circumference here is 12,989 feet, which I suppose we could do that in miles. 12,989 divided by 5,280. So the distance around the park is 2.46 miles. Hey, that's pretty close to the one that's in the book. How many acres does it contain? Well, it contains 13,402,905 feet divided by, and then the air,
so that's the thing you look at right there, and that's what I was talking about with equity and the type of personal equity you build.
5,280 squared tells us how many square miles it is. So it's about 0.48 square miles. How many acres does it contain? So an acre, what did I see that? 4350 was an acre. Was that last lesson? An acre. Yes, it was number 10 on page 190. And it says that an acre is 43,560. So if we take 13,402,905 divided by 43,560, we get about 307 acres. Next one. This isn't quite a square mile, by the way, because if you notice, the radius is much less than a half a mile. This is like number page 194, number 19 with the pulleys. I'd like to show you how this one looks if you figure stuff out. So what we've got here is the wire goes around, around this side of the pulley, around this side of the pulley, and around this side of the pulley. Well, I'm going to draw the parts of the three circles that it goes around. Okay, so there's that circle, correct? This circle, it goes around that part, and this circle, it goes around that part. So if we took just the curved part of each of these and add them together, this part,
If I come back here in 10 years to interview,
and then the top part of the circle, this part here is actually inside out, but it is this part of the circle here. So they all add up to one circle. And these circles have a radius of 4 inches. This distance is, 14 inches, and this distance is 21 inches. So how far is it from where it touches this circle to where it leaves that circle? So we would have a circle of radius 4. So we're going to take circumference, which is 8 pi plus 14 plus 21, and it tells us it is 60 inches from here all the way over. And I think there's one left. It looks from the end. See you later. This right here is 11.8 millimeters is the diameter. That's from one side to the other. Okay, so let's do the conduit, and then we'll do the wires. Here's the conduit area. So we've got 11.8 over 2 is 5.9. 5.9 squared pi is about 109. .3588 square millimeters. The wires inside, notice there's 3 across no matter which way you look at it. So the diameter of each of those wires is 11/8 over 3. Or if you wanted to do the radius, it's 11.8 over 6, because that's half of the radius, squared times pi, and we get, each wire has a cross-sectional area of 12.1, so since there's 7 of them, their total is 85.0569. What we need to do is to find out what the area that isn't full of wires inside here is, or in other words, subtract. So we have 109.3588 subtract 85.0569 is 24.3019. I think that's the last. Oh, we have one more thing. We have to see how far does a tire roll. This is like number 23, so it's 27 7/8 inches across the tire. So what we're going to do is take that 27 7/8 and multiply that by pi, and that's how far forward it rolls, which is about 87.5, about 87 and 9/16 inches forward. Then I think that's it.